we discussed about some of the major changes, right, that we can observe in our day-to-day life, right? So these were the major changes which we have seen, which we have discussed. Like, for example, some of them I can again recognized you. Let's revise them. For example, yesterday I gave you 5 examples where you have to categorize the daily life situations and think what happens when the first example, when milk is left at room temperatures during summers. So you know very well what happens when milk is left at room temperature during summers. Summers, as you know, the temperature is very high as compared to normal. So that's why milk, when left at room temperature during summers, its properties changes. Then an iron tawa is left exposed to the humid atmosphere. What happens when an iron tawa iron tawa or anil pan or iron nail is left exposed to humid atmosphere? It tends to get rust, because humidity means when it is exposed, when the attacking of the oxygen as well as the water takes place, so it gets rust. Or to be more precise, we can say when there is a coating of the rust, that is iron oxide over it. It's a brown color coating, and that's why the entire process is called rusting. It can be prevented by 3 methods which we have discussed yesterday. The first one was your galvanizing, the second one was your greasing, oiling, or painting, and you can use lubricants also. Then we learned about the next example, that what happens when grapes gets fermented. So fermentation is a process in which the sugars, it happens usually in sugars when they are being fermented, they are being converted into alcohols. Then what happens when the food is cooked? When the food is cooked, we cannot convert it into raw materials. Then what happens when the food gets digested in our body? When the food gets digested in our body, we cannot gain it back in the form of
Body.
chemical change. Yeah. So it is a chemical change, not a physical change.
Can you
Last,
please grant me the permission to record?
yeah, sure,
Like
can.
it's asking, please ask the host to give you permission to record.
Okay,
So like,
let, let me ask. Let me tell sir. Just a while. Yeah, sir will give you. Check again.
yeah, just a second.
I will share this recording with you, don't worry. This recording which is being done by us, that I will share with you. Okay.
Okay.
Yeah. So moving forward now, let us revise three of the activities we have done in our last class. As you can see, the first activity I am showing you, this is your chapter number 1. We are starting. So in first activity, as you can see, we have been told that we have to take a magnesium ribbon, which is about 3 to 4 centimeter long, by rubbing it with a sandpaper. So we don't need any much longer length of the ribbon. Thus 3 to 4 centimeter magnesium ribbon is quite enough for us to carry out the experiment. So we'll take a magnesium ribbon about 3 to 4 centimeter long by rubbing it with a sandpaper. And you know very well, magnesium is a metal, right? You both girls know very well. So when the magnesium ribbon is rubbed with the sandpaper, and then we will hold it with a pair of tongs. Tongs, you know very well, we cannot carry the experiment by our hand. So we need to hold it with a pair of tongs. And we will ignite it with the help of the spirit lamp. And as you can see, the as you can see, the magnesium ribbon is burning under the spirit lamp, right? And there will be a white powder which will be collected as in the form of ash. Yeah.
Yeah.
So this ash form is a white in color, that is white powder. And how we are going to show this change in the form of reaction, that we'll come to know. Now, as you can see what is formed, now you must have observed when the magnesium ribbon is burned with a dazzling white flame, because obviously it is a ribbon or it is a metal also. So metal burns with a flame. So it burns with a dazzling white flame. Dazzling means a sparkling white flame, like you can see the crackers, and changes into a white powder. So this white powder is a form of ash, and this powder is magnesium oxide. Now, how we are getting the magnesium oxide? Showing it with the help of example or with the reaction, because this is a change. How we can say that it is a change? Because you know very well that its properties are being changed. From the strip of ribbon, it is converted into the powder. Now what we have taken is, we have taken a magnesium ribbon that is represented by Mg. It is burning in contact with oxygen, that is O2, and it is forming MgO. What is basically happen is, when the metal is burning in the presence of oxygen, it is forming metallic oxide. Right? So this is the change which is occurring, and we are showing it with the help of an equation. And equation is what? A chemical equation is what? It consists of the reactants on the left hand side, and after the arrow it is shown with the help of products. So these are the products which are being formed, and these are the reactants by which we have carried out the experiment. Right? The reactant can be in the form of solid, they can be in the form of liquid, in the form of gas. Similarly, the products can be in the form of solid, liquid, or gas, depending upon the state of the reactants and products. So by this method, we have shown the changes occurring, and by the changes occurring, we have shown it with the help of the equation. Right? Similarly, for a common example, we can say whenever the metal reacts with oxygen, it is forming metallic oxide. Instead of magnesium, you can take any other metal also. Like if you are taking example of an aluminium, utensils are provided there. If aluminium burns in presence of oxygen, it forms a coating of aluminium oxide. Now in this case, we were getting a powdered white powder we were getting, it was of magnesium oxide. But in this case, aluminium, when it comes in contact with oxygen, it forms aluminium oxide. Now this aluminium oxide is a coating and not any solid, liquid, or gas. It is just a coating over your object. Similarly, if you take any other metal, for example, if you take potassium, burns in presence of oxygen, it will form potassium oxide, and this is again a coating. Right? This was your experiment number 1.1. In your second experiments, we have been told that you have to take a lead nitrate solution. When a lead nitrate solution is taken in a test tube, you have to add potassium iodide solution. So what we have to do, basically, we have to take a lead nitrate solution. Now when it is saying solution, it means it is already in the state of liquid. Some water is being already dissolved. That's why it's a solution. So when a lead nitrate solution is taken in a test tube, we have to add potassium iodide solution. Both of them are solution. Now in first case, what was happening? We have taken the strip of ribbon that was in the state of solid, and oxygen was being, it was burned in presence of oxygen. So solid was being burned in presence of gas. Here both of them are liquid. Means in a solution form. Both are the solution. It means that they are in a liquid form, not solid or not a gas. Now, how we are going to show that? What change do we observe here? You know very well, as I told you, that you have to learn the valency chart, the name and the valency. So here I'm going to revise you some of the metals, and then we will carry out the reaction, right? So here I am writing the name of some metals. Okay, I'll ask the metals and I'll write the symbol. Okay, so Sheza, what is the symbol for aluminium?
Aluminium.
Yeah, aluminium.
Al.
Al. Samika, what is the symbol for potassium?
K.
Yeah, K. Sheza, what is the symbol for sodium?
Na.
Na. What is the symbol for iron?
Fe.
Fe. Samika, what is the symbol for magnesium?
Mg.
Symbol for gold?
Au.
Yeah. Sheza, symbol for silver?
Ag.
Okay. Samika, symbol for copper?
Cu.
Yeah. Then Shaza, symbol for calcium?
Ca.
Good. Then Shaza, symbol, I think all of them are covered. What is the symbol for silicon?
Silicon.
Yeah.
Si.
Si. Okay, I guess major of them we have covered. One more. What is the symbol for mercury?
Hg.
Hg. Okay. Samika, what is the symbol for platinum? Samika, what is the symbol for platinum?
Um,
Yeah, platinum. Is it a hard?
no, ma'am, I just don't remember right now.
Okay, platinum is Pt. No problem. Okay, so these are the symbols of some common metals, as you all can see, except I guess silicon is a non-metal. Moreover, on a non-metallic side, rest other them are metals, right? These are the some common symbols which you have to study, which are definitely going to be repeated in this chapter again and again. Okay, now these are the symbol. Now talking about some more symbols. So Shaza, what is the symbol for lead?
Lead is Pb.
Lead is Pb. Any other metals you would like to discuss?
Barium, nitrogen.
Yeah, Shaza, okay. Okay. Samika, what is the symbol for barium?
Ba,
Ba. Good going, girls. Any other symbol, Samika, you would want me to revise if I've forgotten?
uranium,
Uranium is a radioactive metal. Okay, but you'll not require this in this chapter. What is the symbol for zinc, Samika?
Zn.
Zn. Good. So these are some of the metals which will be repeated in this chapter. And after the metals, we are going to discuss about the valencies. Now, a little bit introduction, little bit revision of what is valency. The valency is the valence is the combining capacity of an atom. Like for example, we have we have not studied that there are k element shells present, which was given by Bohr in your class 9. The first shell consists of 2 electrons, the second of 8, then third of 18, and fourth of 32. So maximum, which is the maximum capacity of a shell to fill the electrons, right? And whatever the extra we have the electrons in the outermost shell, that is known as its valency. So basically, the valency is the combining capacity of an atom. Now, for example, if I'm talking about sodium, and sodium has atomic number 11, and we have to fill in these shells. So the first shell will have 2, the second shell will have 8. So 8 plus 2, 10. We have 1 electron left, it will be here. Now, what are the rules to be followed by the when we are filling the electrons, that we have to either complete the duplet or octet. Now, we have to complete 8 electrons here. Now, for completing the 8 electrons, either we can give 1 electron or either we can gain 7 electrons. So, which one is more easier? First step, to lose 1 electron. And since sodium will lose 1 electron and become stable at 2,8, so that's why its valency becomes sodium plus 1. Plus, because it is losing the electron, and 1 because it is losing only 1 electron. So this was, do you know very well about the valencies? It was just a revision for your valency, right? So here I was asking about the valencies of some common metals. So you would be telling now to me the valencies. So Shaza, what is the valency of aluminium? 1, 2, 3. You know very well the metals have positive valencies, right? So I'm not going to write positive in all the cases. Positive, why? Because it is going to lose the outermost electron. Yeah, it's understood. Okay. Shaza, what is the valency of aluminium?
Uh,
Yeah. Aluminium has atomic number 13. So just calculate and tell me what would be its valency.
yeah, just a minute. It will be +3.
Yeah, it will be 3. Then Samika, the valency of the potassium.
Just a minute.
Potassium is, I guess, 19, if I'm not wrong.
Yeah.
One.
Yeah. Okay, the, again, Shaza, the valency for sodium.
Sodium.
Sodium is 11. I told you that just have a revision of the valencies, atomic number. I think you haven't not revised. And you should revise because it is already in class 9. Making of the formulas and the valencies. It has not been eliminated in the syllabus. Okay, tell me. Sodium is 11. So, what would be its valency?
1.
1. Okay. Now, Samika, iron exists in more than one valency. Means it exists in variable valencies. Yeah. So, you can tell any one of the valencies as per your convenience.
2.
Yeah, it exists in valency 2 as well as 3 also. So, how would you classify which valencies to be used? For example, it has been given the question like iron 2 oxide. So it will be given to you that in this case you have to use the valency iron with 2 like this. Okay. Then we have magnesium. Yes, Shazza, the valency of magnesium is?
Magnesium is 2.
Yeah, 2. Gold? Not you, not you. Samika, the valency of gold? 1 or 2?
Actually, last year portion mein it was only till calcium. So
These are common metals. You can guess, okay? No worries.
1.
Valency of gold. It exists in, yeah. The valency of gold is 1. Then silver also we have 1. Copper. Samika, what's the valency of copper? Copper was in your syllabus, I remembered. I have also taught class 9. Copper 1, 2, 3.
2.
Yeah, 2. Then we have copper exists in 1 as well as in 2 state. Both of the state copper exist. In most of the cases, we use valency 1. In most of the cases. We'll tell as per the question comes. So, yeah, Shazab, the valency of calcium? Yeah, calcium. Calcium is 20, if I'm not wrong. 2, 8, 8, 2. Yeah.
it will be 2.
2. Great. Silicon is 3 for your convenience. Let me just tell you. Mercury is 1. Platinum is 1. Lead is 2. Shaza, barium is your favorite symbol?
I don't know.
It's 2. And zinc, Samika?
2.
2. Okay. It was all about the valency of the metals. Now moving forward to valency of some common non-metals or gases. We have oxygen. We have NO2. We have NO3. We have SO4. Yeah, as far as I remember, yeah. We have HCO3. Yeah, since they all are non-metals, more of a non-metallic side, the gaseous state, their all symbol valency will be minus. Yeah. So, Shaza, valency of oxygen is?
Oxygen
Oxygen is 8.
8.
Yeah, it's 8. Calculate. Yeah, calculate.
It will be -2.
Yeah, it will be -2. Good. Yes, Samika, the valency of NO2. NO2 is nitrogen dioxide. Yeah. So valency of NO2, it is 1. If you are confused, then valency of NO3 is nitrate. It is also 1. Sulfate is, can
-2.
anyone? Yeah, -2. It is bicarbonate, -1. Nitrogen is -3. Nitrogen is N2. Here if we talk about it, it's nitrite. Yeah. So today we will learn to balance the equation. Yeah. So in your activity 2, you have been told that you have to take the lead nitrate solution. In lead nitrate solution, you have to add potassium iodide. Both of the girls make the formula and carry out the reactions. Lead is Pb, nitrate is NO3, frame a formula. Potassium is K, iodine is I. Yeah, frame the formula. Both have the symbol valency 1. Frame the formula for this one, then this one, and do the double decomposition. Basically, exchange their ions. Just try out and then we will discuss this equation. Firstly, frame the formula for lead nitrate. Frame the formula for potassium iodide.
Lead nitrate plus potassium.
Iodide. Iodide means iodine, I.
Yeah.
This is a very important question. This time, every time it comes in the board.
I got the answer. I don't know if it's correct or not.
We'll discuss. Carefully, you can revise till Samika is doing.
Yeah.
Yes, ma'am, got the answer.
Got the answer? Okay. So, Sheza, what is the symbol for the lead nitrate?
Lead nitrate is PbNO3.
No. Something you have forgotten. See, lead is +2. Yeah. Nitrate is -1. When you will cross multiply them, it will be 1 will come here and 2 will come over the nitrate. Yeah. So this will be PbNO3 whole twice 2.
Yeah.
Samika, have you got this one correct?
Yes, ma'am, just 2%.
Okay. Can you tell me the formula for the potassium iodide now?
KNO3.
Potassium is what?
K.
K. And iodine is what? Iodide? Iodide. Iodine, same. Yeah. Like chlorine and chloride are same, ClCl. Yeah. So similarly, iodine and iodide are same. So what is the symbol for iodine? It is I. And both have the valency 1, right? Okay. And now we have to form the product. Now you know very well, lead is a metal. It will have the positive charge. And nitrate is a non-metal. It will have the negative charge, right? Similarly, potassium is a metal, positive charge. Iodine is a non-metal, a negative charge. Exchange their ions and form the product. Like positive will go towards the negative one. This positive will go to this negative one. Frame the two other products as per following the valency. And why we are doing this so? Because if you will identify the reaction, it is displacing, the lead is displacing potassium and nitrate is displacing iodine. So it is displacement. Obviously, all are being displaced. But as you know, both the elements are displaced of this reactant, and both the elements are displaced from this reactant. So the classification of this particular reaction will be double displacement. Okay.
Yeah.
Question comes in the exams, classify the following reaction. In this only. This time it has come in the board. So it is an example of the double displacement. Double means both of the reactants are being displaced, and double means two times. Like this is also displaced, this is also displaced. This one is also displaced and this one is also displaced. And how you're going to displace? Positive will displace the negative one. The negative will form the bond with the positive one. You know very well. The opposite charges, they attract each other. That's why we are interchanging the ions of the positive with the other's negative one. Now frame the two other products and let me know the answer. I'll ask you. Lead will be exchanged with the I. So it will be lead iodide. Yeah?
Yeah.
And K will be K potassium nitrate. Frame the two formulas for this equation.
I got it.
You got it?
Yeah.
Carefully check. Might be you have forgotten two or one again. Samika, done?
Yes, ma'am.
Okay. Samika, tell me the first product you are getting.
Ma'am, PbI2.
PbI2. Can you name this? What is this? Name. Word equation. PB is?
Lead iodide.
No, it's not lead. It's lead.
Lead. Yes, ma'am.
Yeah, it's lead iodide. Okay. Shaza, what's the next product you're getting?
KNO3 whole twice.
Again, mistake, beta ji. Potassium is 1. Nitrate is again 1. So from where you're getting this whole twice?
No, it's just
Understood?
KNO3.
Yeah, it's just KNO3. What is the name of this KNO3?
It's potassium nitrate.
Yeah, it's potassium nitrate. So have you understood the second activity? In second activity, we have been asked when you are taking lead nitrate solution and potassium iodide solution. So you are getting lead iodide and potassium nitrate. Now, one kind of another question can be asked from this equation, that when you're mixing both of them, in one of them is going to give you yellow precipitate. So your lead iodide is going to give you a yellow precipitate. That means yellow residue. Precipitate means the tiny droplets. Okay. Now in your third equation, we have been told that this you will do by yourself. I'll just give you a hint. You have been told you have to take some few zinc granules. Yeah. And in the zinc granules, you have to add dilute hydrochloric acid. So Samika, what is the formula for the hydrochloric acid? Samika, there?
Yes, ma'am.
Yeah. What's the formula for the hydrochloric acid?
HCl.
Yeah, HCl. See, hydro and chloric. Yeah, the answer is within the question. Hydro means hydrogen H. Chloric means chlorine, HCl. Understood, Samika?
Yes, ma'am.
There is also one common acid which will come in again and again in the chapter, that is your sulfuric acid. So sulfuric acid is known as H2SO4. Because of this S, it is called sulfuric acid, like sulfuric sulfur. Yeah. So these two acids will come again and again in this chapter. Okay. So HCl hydrochloric acid and H2SO4 is sulfuric acid. Now in the activity 1.3, you have been told you are taking some zinc granules and you are adding some hydrochloric acid to it. Yeah. So you will form again two products. And another part they are saying you if you want to replace the acid, instead of hydrochloric acid, you can take H2SO4, that is sulfuric acid. This is your activity 1.3. You have been told you have to take zinc granules and add dilute hydrochloric acid to it. or you can take zinc granules and add sulfuric acid to it. Yeah. So this frame the equation. Have you noted down that your second equation was an example of the double displacement? Yeah. No, kindly make a note and write it down. The second equation was an example of the double displacement. Displacing means displacing from one element to the other. Now moving over to your question number 3, activity 1.3. Just frame the products and let me know.
I got it.
Check again, Shaza. Sometimes you're forgetting to, sometimes you're putting to. Carefully. And also classify the equation also. Which kind of equation is this? Like displacement, double displacement, decomposition, or combination. Classify it also.
Yes, ma'am, done.
Done? Okay. Samika, what is your product being formed here?
ZnCl2
Yeah.
plus H2.
Okay. So Samika, since you have framed this equation, so can you tell me the state also? Now, since zincs are the granules are basically like you have seen chana in at your kitchen, dana. Yeah. Similarly, zinc granules are we can't say them as a dana in chemistry language, so we call them granules, right? So the state of the zinc will be solid, obviously. The state of the HCl is it is an acid, so it will be liquid, or you can say aqueous also. AQ is also shown in some books. Yeah, so both will work. ZnCl2 will be in aqueous form because you are adding liquid to a solid. Yeah. So your ZnCl2 will be liquid or aqueous, and hydrogen. This H2 is in which state, beta?
Gas.
Yes. Now this particular question has come again in this year of board examination, and they have asked that what happens, or they have asked that give a reaction in which the metal react with an acid, and also tell the gas which is liberated. So understood how the question comes? It is not going to come what and where. They'll ask you in a twisted way. Yeah. So Shaza, in your second reaction, Zn plus H2SO4, what is being formed here?
ZnSO4, which is zinc sulfate, and hydrogen gas is evolved.
Yeah, great. Now, the another kind of question which comes from this topic is the test for the gas. Now, you know very well, in both the cases, hydrogen is being evolved in the form of gaseous state, yeah? So now, a test for the the detailed test will come to you in your lesson number 3. I'm just giving you a small, short, point-to-point explanation of this one, yeah? So the test for the hydrogen is that the experiment goes like this is your flask, and here you have taken some zinc granules, right? And you are adding HCl to it. So basically this is the solid, and you have added the HCl to it, and this is the zinc, yeah? And the gas will be evolved, that is hydrogen, yeah? So from here the gas will enter. This is the setup I'm showing you. This setup is also shown in your book in lesson number 3. You can see in there also. So this gas is again going through a beaker containing the water and the soap solution. So when the gas which is coming from the hair, hydrogen gas, it goes through the soap solution. Yeah. And when it goes through the soap solution, so test for the hydrogen is that when you bring, there are two tests, but the test which is in your NCERT is that when you are bringing a burning matchstick to it. Yeah. Burning, it can be matchstick, it can be candle, it can be splinter. So when you're bringing burning matchstick to it, it will give a popping sound. Like you might have seen a toy when which you blow from the mouth and a sound comes from that. Yeah, popping sound. That kind of sound will be blown. So when this hydrogen gas, for example, the hydrogen gas is evolved from here and you will bring a burning matchstick near it, then a small popping sound will come. Not a large amount of sound will be coming, but a small amount of sound will come. Yeah. So this is an important test for the hydrogen. Okay, so we have covered our activity 1.2 here, 1.3. Now here you can see this is your activity 1.2. These are the zinc granules. Yeah, and this is the sulfuric acid. Same, it can be for the hydrochloric acid also. Hydrogen gas is being evolved here, and you can bring a burning matchstick, burning splinter, burning candle towards it, and a popping sound will come. So this is a test for the hydrogen. Your next topic is the chemical equation. Now you know very well. You have framed just now 4 chemical equations in front of me. One for the magnesium, 2 for the zinc, 1 for the lead nitrate. So what have you noticed? What is a chemical equation? I would like to know from you both. A point each. Yeah, we'll start from Samika will start. Samika, don't look on the book. Just now you have framed some of the equations. As you can see, this was also an equation. This is also an equation. This is also an equation. So what conclusions would you like? What views or what a different definition would you like to give me for this chemical equation? What is a chemical equation according to you?
Like a reaction with which includes symbols.
Okay. A reaction which includes symbols. Shaza, can you little bit arrange this definition? Symbols like in the form of what?
Chemical equation is basically reaction taking place where reactants react to form products or
Yeah, a bit better. A good efforts from you. Okay, so Samika, what can you give me some rules to write down the chemical equation, as this is a chemical equation, it is following some rules. Or either you can just tell me what symbols, not symbols, I'm not asking that Zn for zinc. I'm asking you the rules, how we have framed a chemical equation.
Whenever we are using an element, we have to write the first letter capital. Like
Look, for the chemical reaction to form, you need the things. So we cannot say the things, we need the reactants. Yeah. So the first important step for framing a chemical equation is that you require the reactants. They can be in the form of solid, they can be in the form of liquid, they can be in the form of gas. Yeah. So first important rule for writing down the chemical equation is that you need to require reactants. And when the reactants, they react, they combine, they decompose, they can do anything with each other, and then they form the products. Now, Shaza, can you just tell me that how can we differentiate between reactants and products in a chemical equation? Why can't I call zinc chloride reactant? Yeah, like my life, my rules. So why can't I say zinc chloride as reactant?
uh,
Yeah.
you have to
Any answers?
that is basically a combination, right? So
Yeah. Can
reactant
you
can't
both see an arrow is here?
yeah
Yeah. So on the left hand side of the arrow, what do we write here? What are these both?
reactants.
Yeah. Samika, at the right hand side of the arrow, what do we write here?
product.
Yeah. So what is going to differentiate your reactant with product is this arrow. Yeah. The arrows are always written on the left hand side. the reactants are always written on the left hand side and the products are always written on the right hand side. And what is the work of this arrow? This arrow is telling you that the reaction is going from left to right. Yeah. For example, if I reverse the arrow, for example, now in this case, I am reversing the arrow and I am making this arrow on this hand side. Now what it is showing? Now in this case, this has become the reactant and this has become the product. Yeah. So this is the role which is played by the arrow. And also this arrow is telling us the direction from where the reaction is going. Like this is combining to make this. Yeah. So this arrow plays a very important role in the chemical equation. Now our next topic in the book is chemical equation. I guess I have understand you very well what is a chemical equation, how it is written. Now if the equation comes in the form of two types, either they can tell you to write down the word equation. Word means in the form of words. Yeah, just now you know very well we have framed this equation in the form of symbols. Yeah, just now we did. So this format is known as the word equation. Yeah. And when they're asking you to use symbol, they will make sure that they will mention you that write the chemical equation. Yeah. So when they are mentioning you the word, you will use the word. Whenever they're mentioning you the symbols, and you will going to make the symbol. Now, what are the rules? Now you know very well when the reactants they combine with the products. So this arrow is acting like a equal to sign. Like in maths, you know that x is equal to 5. So what it is showing that the value of x is 5. Yeah, or 5 is equal to x. Now in this the chemical equation, I told you the work of this arrow. Now this arrow is telling us that it will tell us, you all have read the laws of the equation, law of conservation of mass, law of conservation of energy. In various physics also you might have read, in chemistry also you might have read. So what does the law of conservation of mass state? That mass can neither be created nor be destroyed. Similarly, law of conservation of energy states that energy can neither be created nor be destroyed. Yeah, so it means when it can neither be created nor be destroyed, so it must be equal. Yeah, so when we are carrying out any chemical equation, it means that our reactant must be equal to product, because we are following which law? We are following the law of conservation of mass. Yeah, so law of conservation of mass will state that how many atoms are present in the reactant will be equal to the how many atoms which are present at the product. Now, as let's us see, the zinc has nothing, means it has 1. Yeah. On the right hand side, zinc is having 1. So it means the zinc is balanced. Yeah. Moving forward to the next element, you have to classify individually. Hydrogen is here 2. On the right hand side, hydrogen again 2. So hydrogen is also balanced. Then sulfur S is 1 and S is again 1. Right? Individual element you have to take. Again, oxygen is 4 here and oxygen is 4 here. So in this case, our reactants are equal to products. Our equation is balanced. Another type of question comes from here, that why an equation needs to be balanced? Because it is following the law. Which law? The law of conservation of mass, which is telling us that all are in the state of equilibrium, like the number of reactants are equal to the number of products. And now what are the rules for writing down the equation? The first rule of the equation is that you have to use the numbers. Like you know very well, do we need to require any numbers to be put here? Yeah, can you tell me, both of you? First you tell me, Shaza, do we require anything to balance here?
No.
No. And why do we don't require anything to balance here, Samika?
Ma'am, because the new element will be formed, like combining two.
No, I'm asking you that why can't I put any number here? Why can't I put 2 here? Why can't I put 3 here? Why can't I put 4 here? Why? I can put, but why cannot put? Because the equation is already what?
Ba-
Balanced. Understood, Samika?
Yes, ma'am.
If we will put any other number, then the equation will be disbalanced. And when it will be disbalanced, will it obey the law, Samika?
No, ma'am.
No. Understood? So the first rule while writing the equation is that you have to use the numbers, and the numbers must be natural numbers like 1, 2, 3. Avoid using the fractions. Yeah. For example, I'm giving you a simple equation which you have read in your smaller classes. H2 plus O2 gives H2O. You have read this equation from very small classes, right? Now, in this case, as you can see in the reactants, hydrogen is 2 here. And Samika, how many hydrogen are here?
2.
2. Now, Shaza, how many oxygen are here?
2.
And how many oxygen are here?
0.
It's not 0, it's
It's
1.
1. 1.
Yeah. Is the equation balanced, Samika?
Yes, ma'am.
How?
Just a minute.
No, I'm asking, is it balanced or not?
It is not, because oxygen has 2 atoms and in the product side it does not have 2.
Yeah. Now here in this case, hydrogen we have 2, oxygen we have 2. Here hydrogen we have 2 and oxygen we have 1. Now how this 1 can be converted to 2? Now again, the rules. We cannot add any number. We cannot subtract any number. Like you cannot do your manmani that it is oxygen is 2 here. So you are writing 2 here. It will change the formula. Yeah. So the first rule for writing the chemical equation is that you cannot change the formula as per your convenience. Yeah. If you want to change an equation, if you want to balance it, the first thing is that you cannot change any formula. You cannot put as per your convenience 2, 3, 4 any number on the formula. Now where you can make changes is here in front of the formula where the space is here. Yeah. Now the oxygen is 2 and here an oxygen is 1 here. Now we cannot add, we cannot subtract, we can just multiply. So 1 can be converted to 2. Samika, how we can convert this 1 into 2 by multiplication? Are you there, Samika?
Yes, ma'am.
Yeah. So how can this 1 be converted into 2 with multiplication? Yeah, it's a very simple question. We have to convert this 1 into 2 by multiplication. How can this 1 be made 2?
Ma'am, by multiplication.
Yeah, by multiplying with what?
2.
Yeah. So this 2, you know very well now you have to use this 2. But how you're going to use this 2? You cannot add this 2 in between the formulas. Okay. You have to just use numbers in front of this. This whole is a formula and you have to use here. You cannot write 2 in between the formula. Okay. So this is your third rule. While writing a formula, don't just interfere between the formulas. Yeah. So oxygen is 2 here and now you can see the oxygen we have put 2 here. Now check. Oxygen is 2 and oxygen is 2. 2 here, 2 will be multiplied with this oxygen. So 2 oxygen. But just check hydrogen. Hydrogen is 2 2s are 4. And here the hydrogen is just 2. So Shaza, is the equation still balanced?
No.
No. Now how can this 4 be made 2?
You need to remove the
We cannot
major-
remove. If we will remove this, then your oxygen again will get balanced. We can just add.
No, not that one. Niche wala 2, if you remove, there
We
will be two
cannot change the
hydrogen.
formula.
Right, never mind.
This is hydrogen with 2 and this is hydrogen with 4. This hydrogen must be converted, 2 will be converted to 4. How?
I did not get you.
This 2, you have to make it 4 by just multiplication. Only multiplication is allowed. So how this 2 can be made 4?
You put a 2 beside H.
Like this?
Yeah.
Okay, now check. Hydrogen, we have 2 2s are 4, right? And on the right hand side, we have hydrogen 4.
Yeah.
Oxygen, we have 2 here. Oxygen, we have 2 here. So I'm summing up the rules. The first rule which you have learned from this equation is that you have to use the numbers, but the numbers must be in the natural numbers 1, 2, 3 and so on. Yeah. Secondly, you have to not interfere between the formulas. Yeah. For example, it is H2O. You cannot put anything here. For example, it is HCl. You cannot put anything in between. You have to just put here in the front section. Whatever numbers you are putting, they must be the multiples of each other. Only multiplication is allowed. No addition, no subtraction, no division, nothing. Only multiplication. Yeah. And importantly, just check the left hand side is equal to right hand side of individual element. Giving you some questions. Just write it down and I'll ask you. Yeah.
Yeah.
Take the test of it tomorrow with them.
Yeah, they'll just perform some of the examples and then we'll take this test, because without this, they won't be able to perform further in this chapter.
Because Sheza is not focused in the class today.
Yeah, I can see a little distraction,
She
but she's
continu-
answering well.
No, she's continuously smiling on something or the other while you were teaching. That she must be knowing where she was smiling. All well, Sheza?
Yeah.
Okay. Focus.
Okay, some of the 2-3 examples I'm giving you, both just practice and right now just solve these equations.
These questions are in their homework, right?
They can do just, it will hardly take a minute.
ठीक है.
Yeah, you have just 3 questions. Check. Okay, one more we can give you. We have 5 minutes. Yeah. You have these 4 questions. They are going to hardly take a minute to solve. Just
So
keep focused. Yeah.
So we are supposed to say if it's balanced or not.
No, you have to balance them. They are already imbalanced. They are unbalanced equation. You have to balance them. As you can see, chlorine we have 2 here, chlorine we have 1 here. So it is not balanced. Yeah. So you have to balance them. Balance using numbers. Numbers should be always placed in front. You can't change the formula. No interference in the between. No fractions to be used. Just multiples. Note down the questions first. Samika, are you writing?
Yes, ma'am.
Again, I'm saying you have to learn the symbols and the valency by heart. Without this, you won't do anything in this chapter. That's why I told you on before and on Saturday that come with a revision of the symbol and the valency. Yeah.
Tomorrow in the
Today,
first of the class, now ask them these things, whatever you have told them.
I have asked today revise them also, but on tomorrow I'll again take a different form of test.
Were they able to answer any one of them?
Yeah, they were answering. But Sheza,
Acha.
as you told me that some of them were in your syllabus, but now from 9th you have come to 10th, yeah? So you can't say that gold is not in our syllabus and silver is not in our syllabus. It will be there, yeah?
Samika, keep the camera on. You are not visible, neither you are audible.
Yes, sir. Right now I can't.
What happened? Like somewhere in the outside of the home?
Yes, sir.
You were sitting in the home. How you are outside now?
No, I'm not outside. Someone has just come and my dog is.
Okay, okay. ठीक है.
Samika, have you done the first part?
Yes, ma'am.
Can you share the answers? First, you tell me, is it balanced or not?
No, ma'am, it is not.
Okay. So, as you can see, hydrogen is 2 here, hydrogen is 1 here, chlorine is 2 here, and chlorine is 1 here. Yeah. So, this is 2 and this is 2, and there we both have 1. So, you have to make 1 which is equal to 2. So, what you have done?
We have added 2 besides actually.
2 you have added where? Here at this
Yes,
point?
ma'am.
Good. Okay. Shaza, in the second equation, as you can see, aluminium is balanced, but chlorine is not balanced. Yeah. Chlorine, you have 2 here. Chlorine, you have 3 here. So now 2 and 3. We don't have any common. Do we have anything common?
No.
So how you have balanced them? In this case, try to use a common factor which comes in both the table. So the least common factor which is going to come in both the table is
1.
1 is already there, beta. More than 1. A number bigger than 1. A common factor which comes in the table of 2 as well as 3. The least.
6.
Yeah. So how you are going to make 2 which is equal to 6 by multiplying it with?
Can you repeat?
Yeah, we have to make, I told you to use a common factor. Yeah. So common factor you told me 6. So this 2 you have to make which is equal to 6 by multiplication. So how this 2 will become 6?
When you multiply it with 3.
Okay, I have multiplied this 2 with 3 here. Now again, now here we have 3 2s are 6. Yeah. And here we have 3. Now this 3, how you are going to make it 6?
When you
Yeah, when we multiply it by
2.
2. Okay. So when this 2 is multiplied by 3, now we have 6 chlorine atoms here. Yeah. And when this 3 is multiplied by 2, we have 6 chlorine atoms here. So chlorine is balanced. Can you see? But
Yeah.
as you can see, the aluminium is disturbed. Aluminium, we have 2 aluminium here. Yeah. And aluminium, we have 1 aluminium here. So how many aluminium should we put here? Aluminium is 2 here. Can you see?
Yeah.
And in left hand side, we have just 1 aluminium. So 1 aluminium needs to be made 2 aluminium by multiplication. So what we are going to put?
2.
2. Now check, is your equation balanced? It was 2 aluminium here and 2 aluminium here. 6 chlorine atoms here and 6 chlorine atoms here. Now the equation is balanced?
Yeah.
Great. Coming towards your third equation, as you can see, the zinc is balanced in both the cases, but the chlorine and hydrogen are not balanced. Yeah?
Anuma, give this one in their homework, the last two
Yeah,
one.
they can do homework. Okay.
Right?
So let's
And
run
they have to send it not by tomorrow. They have to send it in next 15 minutes.
Okay.
Is that fine, Sheza? Can you just take the picture and send us?
Yeah, sure.
Right? Just send us and just solve it and send us.
Yeah.
Okay,
Okay.
Samika and yeah, Shaza, you both can do and send the picture, okay?
Have you noted down this one?
Yes,
Yeah.
sir.
Tomorrow we can place a test also of this particular thing. Yeah?
Yeah.
Yes, sir.
Okay, just revise it. Okay.
Okay. See you tomorrow.